Hey there, everybody. Welcome back to our second set of notes on talking about the mole. Today we're going to talk about something called molar mass, which is really starting to get to the point of why we even talk about the mole in the first place. So you'll remember that a mole is really just a measure of stuff. It's a really big number, 6.02 times 10 to the 23, and we can use that to count atoms or particles or molecules or whatever we want. And the reason we need such a big number is because atoms are so small. So instead of measuring them out by 10 or 20 or 100 at a time, we measure them out a mole at a time. So when we start to make compounds, which is to combine things together, so a compound is a combination of atoms. Okay, and so we can see different examples of compounds, like for example NaCl or H2O. And so we know, for example, NaCl is an ionic compound, and we know that H2O is a covalent compound. For the purposes of finding the molar mass, it doesn't really matter whether we're dealing with ionic or covalent. You just need to know what the chemical formula is. So what is a chemical formula? Well, a chemical formula is basically just reducing the compound down to its constituent parts. So the chemical formula just tells us the constituent parts of a compound. Now, what do we mean by that? Well, a chemical formula, for example, NaCl or H2O, just tells me exactly how many sodiums and chlorines or hydrogens and oxygens I'm dealing with in one of these compounds. So how many atoms of each type are in the following compounds? So my first compound there is K2CO3. That's something called potassium carbonate. And so I'm going to count up the number of atoms of each individual type that I have in this compound. So for potassium, we can see that for potassium, I've got 2 atoms. For carbon, there's just 1 carbon. And then for oxygen, there are 3 oxygens. Now for our next one here, CaC2H3O2, which is calcium acetate. I've got 1 calcium, so that's really straightforward. But don't forget here, when I've got this bracket situation happening, that what it means is I've got whatever's inside this bracket, I have 2 of those whole things. So when it says C2 here, I've got 2 of those. So for my carbon, that means I have a total of 4 carbons. And for my H, I have a total of 3 times 2, that's 6 hydrogens. And for my oxygen, that's 2 times 2, which is 4 oxygens. And the last one here, NH4,3N, that is something called ammonium nitride. And so how many nitrogens do I have? Well, I've got in my ammonium, there are 3 ammoniums, so that's 3 nitrogens, but then there's another nitrogen on the outside here. So that's a grand total of 4 nitrogens total. And then for my hydrogens, I've got 4 times 3 is 12 hydrogens. So when we talk about the molecular mass of some species, whatever it is, okay? So the molecular mass of ammonium nitride or water or whatever it is. So the molecular mass is really just the sum of the masses of each atom that make up the compound. Now, we could measure this in atomic mass units, which is really just the mass of individual atoms. But that's not really going to be very helpful because we're not going to react individual atoms. We're not going to react them 1 or 10 or 100 at a time. We're going to react them an entire mole at a time or 5 moles at a time or whatever it is. So instead of molecular mass, we're going to use molar mass, okay? And the molar mass is the mass of 1 mole of that compound. And since it's the mass of a mole, then that's measured in grams per mole. So let's do just a few examples here, all right? So the first one we're gonna do is, what is the molar mass of NaCl, or sodium chloride? Now the first thing I wanna notice is if we jump over to our periodic table, the periodic tables tell us the masses that we need. Now I'll just point out here that let's take a look at, let's say hydrogen. You can see hydrogen right here, right under the H, there's a number 1.01. And it tells me over here on my key that that number is giving me the average mass. I want to point out that that is both AMU and molar mass. So it's both molecular mass and molar mass. What that means is one hydrogen atom would have an atomic mass of 1.01 AMUs. That happens to be the exact same as the molar mass measured in grams per mole. So for example, if I hand you 1.01 grams of hydrogen, I'm giving you exactly 1 mole of hydrogen. And it's worth pointing out that these are the average masses, they're not exact numbers. And that comes down to the fact that these different elements are made of different isotopes of that element. And so really we're taking the average overall. Okay, we'll talk more about isotopes later. So for now, I need to find the mass of sodium chloride. Well, sodium is right here. And sodium, you can see, has a molar mass of 22.99 grams per mole. And chlorine is over on this side. It has a molar mass of 35.45 grams per mole. So I'm going to set it up like this. I'm going to say I have so for sodium, that's just going to be 1 times 22.99. And my chlorine, there's only one of those, so that's multiplied by 35.45. And when I add these up, I get 58.44 grams per mole. Okay, so let's try this now with H2O. So again, I'm going to jump back to my periodic table over here, and I see that the molar mass of hydrogen is 1.01. and the molar mass of oxygen is 16.00. And so I'm going to say, okay, I've got my H's and I've got my O's. There's 2 hydrogens and they each have a mass of 1.01. And there's 1 oxygen with a mass of 16.00. So don't forget to multiply that by 2 before I add them together. And it's going to add up to 18.02 grams per mole. All right, now I've got, what's the molar mass of magnesium chloride? So I've got, for my Mg, I've got just 1. And for my chlorine, I've got 2. And so let's jump over to our table and check the molar masses. So magnesium, where are we, is over here, 24.31. And I remember chlorine is 35.45. So this is 24.31 and 2 times 35.45. Now when I add those all together, I end up with 95.21 grams per mole. And one last example here that gets a little bit complicated. So I've got aluminum sulfate. So let's count up our atoms first. There are 2 aluminum atoms, and then there are 3 sulfur atoms. And then for oxygen, I've got 4 times 3. That's a total of 12 oxygen atoms. So I need to multiply each of these before I add them all up. So let's go over to our chart here. Aluminum is right there. It's 26.98. So that's 26.98. And then let's check sulfur. Sulfur is 32.07. So 32.07, and then I remember that oxygen is 16.00. Now don't forget to multiply those before you add them up, but when you do, we get 342.17 grams per mole. Okay, so it's a fairly straightforward process. You just find the individual number of atoms and then add them up and find the total. I want you to go ahead and try these next 4 on your own. And in this case, I haven't given you the compound. I haven't given you the formula, whereas I did in this last one. So here you have to first figure out what is the formula. Once you have the formula, then work from that and find the molar mass. And of course, I want you to hit pause in the video and try these before you get the answers. And you definitely will pause it. And you definitely now have already paused it. And now you're finally coming back with your answers. And you're not cheating and just looking ahead. But here's the answers you should get. Carbon tetrachloride is CCl4. Iron 3 sulfide is Fe2S3. Ammonium nitrate is NH4NO3, and manganese 6 phosphate is MnPO4 3. And there are the answers. Okay, so that's it for molar mass.